let's now travel through space. Proxima Centauri is the closest star to Earth. The word proxima in Latin, it means proximal, close to. It's 4.24 light years away. What's a light year? A light year is a measure of distance. It's not a speed. It's not a time. I know it has year in it. It's not a time. It's how far light travels in 1 year. How far does light travel in 1 year? A long way. I'm just going to leave it at that. It's a big distance. So we're going to start to put our time in light years, but that's not going to be a problem because I said to you last day, Matteo, Einstein's equations don't care about your units as long as whatever units you put in, those are the units you'll get out. Alrighty. Let's suppose we build a spaceship that can travel 80% of the speed of light. Okay. How long will it take the spaceship to get there as measured by stationary observers on the Earth? Let's underline this here. So this is us back home. Misha, how long do we think it takes to get there? So here's the question. Are we moving, Christy, if we're on the Earth? Are we moving? Here's the key word. Christy, my angel. What word is that right there? So we're going to assume Earth is at rest. Okay? Sierra, are we moving? No. So do we need to bring in relativistic equations? No. For us here on Earth, we don't use relativity all the time because in our frame of reference, we can assume we are at rest. Einstein said, go ahead. So, you ready? What does this question want us to find? Don't overcomplicate it. What does this question want us to find? Time? Are we moving at speeds near the speed of light? Everybody say no. Dylan, part A, we're talking back home on Earth. On Earth, are we moving at speeds near the speed of light? Say no. So do we need to bring in Einstein stuff? No. Now we're still going to say A is 0. What's the speed? Well, hang on. We want to go, the speed that we're traveling is 0.8 of the speed of light. And what's the distance to this star? And I think I misspoke. I wasn't careful. I'm going to abbreviate, by the way, light years as L period Y period. I don't know what the actual abbreviation for light years is. I think I misspoke. Brian, I said, what's the speed that we're traveling? What's the speed that the spaceship is leaving away from us at? 0.8 c? We can use the equation that we've been flogging to death this unit, which is this one. That's from relative speed, relative velocity. In fact, that's what we used to do the Pythagoras to get Einstein's equations. Brian, how would I get the t by itself? Okay, so back on Earth, this is how long we think it's going to take. Emma, we're going to go the distance divided by the speed. Emma, my angel, what's the distance? Units? Here's why. Watch. I'm going to write 4.24 L period Y. By the way, I think I said this before, but if not, whenever I write an L, lowercase, I'll always write it in cursive, because if I write it like that, what number does that look like? So I'll always, it's a habit I've developed, it's a good one to pick up for you folks as well. Whenever you're writing a lowercase L, make it a cursive one, so you know it's not a 1. Divided by, what's our speed, Emma? Thank you. Now, you ready? What does the C stand for? The speed of? We can sort of say that this light and this C will cancel, and this gives us an answer in years. That's a bit wrong, but trust me, the math works okay. So on your calculator, can you go 4.24 divided by 0.8? Which is what? 5.3. I'll use my lowercase a now for years. So Emma, how long to get there and come back? 10.6. Let's suppose you spend a year exploring. So we would say, as far as we're concerned, This is about an 11.6 or 12-year mission, but let's just stick with the 5.3. Let's just, to keep the math simple, go there. How long do we think it takes? How much time will pass on the Earth? Everybody? 5.3 years. Because on the Earth, are we traveling at relativistic speeds? No. So we can use distance equals speed over time. Jacqueline, what does B want me to find? Time. On the spaceship, are they traveling at relativistic speeds, near the speed of light? So we can't use D equals VT. So now I'm going to ask you, which time does this question want us to find, T or T0? Ah! What's T? How much time passed on the Earth? That's why I had to do A first. 5.3. With me, Joel? What's V? Still 0.8 C. Can you look at the green sheet? You need to get the T0 by itself. How would you get the T0 by itself? What will you do with that big ugly square root? Hello? You need to get the T0 by itself. How will you get the T0 by itself? What will you do with that big ugly square root? What's that big ugly square root doing to the T0, Hannah? How will I move it over? So if I hear you, you're telling me I'm going to go, and that's one I'm going to expect you to handle, okay, T or T0. You're telling me we can go T0 equals T times 1 minus V over C all squared? Okay. .3 square root of 1 minus 0.8 C over C all squared. Maggie, do you see? Do you see? You see? What do you see? What cancels? C. So it's, how are we going to type this? And again, some of you have better calculators than I have, especially the fancy schmancy ones that have the orange buttons. You can probably type it a little quicker, but I always, Maggie, do what's inside the square root first. 1 minus 0.8 squared. I hit equals. Please practice typing this into your calculator. I go square root of that. This time I'm not dividing the square root. I'm now 5.3 times that answer. Yes? So how much time elapses on the spaceship? 3.18 years. Here's where it gets weird. How far away is Proxima Centauri from the Earth? What did I say in the very, very beginning of the question? Sorry? Loud and proud?
4.24 light years.
One more time, not to make fun of you, but for a very profound reason.
4.24 light years.
No, it's not. Turns out another consequence of Einstein is there's no such thing as accurate distance in space. You cannot measure the distance from one place to another. You ready? Because let's suppose the spaceship was also laying out a big tape measure. This is an imaginary experiment. As it flew along, and it was going to measure the distance to the star. Now, as far as we're concerned, how far away is it from the Earth?
4.24 light years.
What about for the spaceship? Well, if the spaceship now goes distance equals speed times time, how fast is the spaceship traveling?
0.8 C.
How much time elapses on the spaceship? 3.18 what?
Years.
Say it again, not to make fun of you. 3.18 what?
Years.
Look up, look up, look up, look up, look up. Light years. Ah. So we are going to get an answer in light years. Go 0.8 times 3.18. This is how long they would measure the distance to be. What'd you get, Mateo?
3.514.
What? We think the star is 4.24 light years away. We send a mission to double check, and with an accurate tape measure, Nick, how far away is it as far as they're concerned? There's no such thing as distance that can be measured and getting the same answer in outer space. In fact, next lesson you're going to learn that when you're traveling fast, and this is a consequence of Einstein and light, space-time itself compresses in the same direction as you're traveling, and distances actually get shorter. Emma gave kind of a, yeah, there's some cool weirdness going on here. So how far away is Proxima Centauri? Depends, I don't know. How far away is Proxima Centauri if we use the Earth as our fixed reference point and assume that we're traveling at a speed of 0? Well, then I guess we can say that it took the light 4.24 years to reach us. It gets weirder, but cooler. Oh, I like example 5. I like example 5. I like example 5. Example 5 is a nice question. Next page. Let's use our imagination, Oliver. Suppose you were a beam of light, a photon. Let's suppose you were a light particle, a photon. How much time would elapse for you? We want to find T0. Okay. How would I get the T0 by itself? Because we're the traveling photon. It's the time on board the photon. How would I get the T0 by itself in our equation? Go look at the time dilation equation. You need to be able to do this. How would I get the T0 by itself? Oliver's getting his sheet out. I like that. What's the square root doing to the T? How will I move it over? So it's this one, yes, folks? Time on board is T times the square root of 1 minus V over C all squared. Okay, I'm not sure what to do with the T. I'll come back to that. Square root of 1 minus. If you're traveling at the speed of light, what's your speed? It's meant to be a stupidly obvious trick question. If you're traveling at the speed of light, what's your speed? The speed of light. What symbol do we have for that? So you're going to get C over C squared. Mateo, do you see? What do you see? Huh? Oh, he's not only do the C's cancel, but anything divided by itself is 1. So you're telling me this is going to be T times the square root of 1 minus 1 squared? Put your calculators down. You don't need a calculator. Joel, what's 1 squared? What's 1 times 1? What's 1 minus 1? What's the square root of 0? What times itself equals 0? What? So I get time times 0? What's anything times 0? If you're a photon of light, how much time do you experience? Nothing. So, coming back to Michael. As far as we're concerned, how many years did it take that photon of light to get from Proxima Centauri to us? 4 point. As far as the photon of light is concerned, it was instant. It left, it arrived. We like to say that it takes light from the sun 8.5 minutes to get to us. That's only relative to us. As far as a beam of light is concerned, it was instant. We like to look up late at night, and we like to think to ourselves when we're looking at the stars far and far away, we get a shiver of wonder. The light from that star left thousands of years ago because it's thousands of light years away, and it's been traveling for thousands of years to reach us. That's a very egocentric philosophy. As far as the light beam is concerned, its travel was instant. Light does not experience time. I told you light was special. Come on, Christy, there's got to be nothing? Not even a little bit of a shiver down your spine? Okay. So, I wrote down here, even though for our stationary frame of reference on Earth, we say that it can take light from stars thousands or millions or hundreds of millions of years to reach us. In actual fact, relative to the photon, how much time has passed? So does a photon experience time? Brian, yes or no? So you ready? Emma, this is for you. I'm going to try and wow you. I've got my phone plugged in here. Is there light coming from my flash right now? I have just created photons. Do those photons experience time? As far as those photons are concerned, even though relative to us, I just created them, do they experience time? As far as they're concerned, they saw the Big Bang at the beginning of the universe, and they'll see the end of the universe because they don't experience time. They've seen it already, and they're there already. Think about that for a while. Come on, there's some... Wow. Light is special. Don't take it for granted. Light is special. Example 7. What's weird about example 7? What's different from all the ones we've done so far? Everything's been weird today, Mr. Do-It. Okay, I shouldn't have said what's weird. What's different from the examples that we've been done so far? Mateo. Okay, I didn't give you the speed as a percentage of light. All right. What's this question asking me to find? Time. Which one? Time on board, time 0, or time back home on Earth? T0. So let's do our standard approach. T0 equals question mark. That must mean that they told me T back on Earth. Rihanna, what was T back on Earth? Did they tell me? 100. 100 what? Units? So this will give us an answer in years. If it said 100 hours, this would give us an answer in hours. If it said 100 minutes, it would give us an answer in minutes. V this time is 2.85 times 10 to the 8th meters per second. Mr. Do-It, that's per second. Don't I have to make that years? No, trust me. Einstein's equations are independent of units. But is this a percentage of C this time? No. So Maggie, this time, will I see? So this time we actually have to write down what C is. C, I put it on your green sheet. How big is C actually? I'm going to use scientific notation. I'm sure I put it 3 times 10 to the 8th, yes? And that's also in meters per second. We want to get the T0 by itself, because I don't think your equation has the T0 by itself. How would I get the T0 by itself? Is that where you... Sorry? This is where we times the square root over? Yeah? Or no? Yeah? Okay. So it's going to be T times the square root of 1 minus V over C all squared. And if I plug in numbers, it's going to be 100 square root of 1 minus, and I got a pretty ugly fraction, 2.85 times 10 to the 8th divided by 3 times 10 to the 8th, and then don't forget the squared. Get your calculators out. Now we're going to go in even more detail. I'm going to do the little mini fraction first. So I'm going to go 2.85. I'm going to hit my scientific notation button. 8 divided by 3, scientific notation button. 8. Now we did do the scientific notation button at the beginning of the year. If you can't remember where yours is, I'll show you later on in the lesson. And I get 0.95. Is that right? Now, move out of the bracket. What's the next thing I'm going to do? Squared. I hit my x squared answer button. Now, move a little further out. 1 minus that. Move a little further out. What's next, Chloe? Square root. Final step. Times 100. Is that right? So, 100 years on the Earth. How many years are going to go by on the spaceship? 31.2. I forgot to put this equation on last year, and I was trying to hope and see if I did remember to put it on this year. Last one. I think it's the last one. Yeah? Yeah. Oliver, what's example 8 asking you to find? Fast. Which variable in Einstein's equation is the fast one? Yes. Well done. Get a little nerdy thrill when you saw that? I'm doing Einstein. What did you learn in school today, Oliver? Mummy, 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 I learned about time dilation. Oh, Oliver, you are ever so clever. Right, you can get him, right? All right. Here's the tricky part. There's 2 times. I see 20 years, I see 10 years. So one of those is T0, one of those is T. This is the part you'll have to memorize, how to tell T0 and T apart. Which one of these is T0? What's a dumb way to remember? How did I tell you that you could remember that T0 was on board the spaceship? Okay. So that must mean 20 years. Now, you can also remember, because, Emma, if you really wrap your brain around Einstein, the moving object has the smaller time. But I'm looking for a clever way. Oh, what are we trying to get by itself here? V? I've done it in the past with kids, and we've done the algebra. But I think if you look on your green sheet near the bottom, don't I have an equation that has a V by itself and has the T and the T0 in it? You should, by the way, I think there's actually 3 equations that have the V's by themselves, because I haven't done all of Einstein's equations with you yet. That's going to be next lesson. But there is an equation with a V, yeah? I don't have this one memorized. Hang on. C outside, big square root, 1, keep going, minus, and I always remember it's either T0 over T squared or it's T over T0 squared. I can't remember which one. T0 squared. So I can go T0 over T squared, or because squared on the top and bottom is the same as doing the fraction then squaring it, right? Okay. You don't have to derive that or memorize that. I put it on your sheet. I was mean. The first year I did this, I made the kids, we derived it and then we physically added it to the sheet. It's about 8 lines. It's heavy duty. All right. By the way, this is how I made up most of your homework questions. I didn't actually start saying find time. I said I know what I want the time answer to be. How fast do I need to go? Which is really, probably someday what we would be more interested in. What's C? Leave it for now. We'll put it in as a number if we need to. Square root of 1 minus 10 over 20 squared. One minus bracket 10 divided by 20 squared. Or you could do the fraction first, 10 divided by 20, and then square it, and then go 1 minus that. Yes? 0.75. Square root of that. And you get 0.866. So one way to write this would be 0.866c. Hey, can't I write that as a percentage of light? What percent of the speed of light is that? No, not 86%. I would take 87 if you, or 86.6, but how would you round down to 80, right? This is 86.6% of the speed of light. I didn't write the speed of light, I wrote a c. I'm going to give you on your test a question or two or three where I ask you to find the speed, and I may say leave your answer as a percentage of the speed of light. Put a part B, convert to meters per second. Or I may say convert your answer to meters per second. How would I convert this to meters per second? I would go back here with that 0.866 times by 3 times 10 to the 8th. It's not 300,000, by the way, people. Whoever keeps saying 300,000, you're wrong. 300,000 kilometers per second, but we do physics. It's 3 times 10 to the 8th, which I think is 30 million, 300 million, I think. So stop saying 300,000. Just say 3 times 10 to the 8th. It's the universal constant. It deserves your respect. And I've tried to convince you that light is extra special. By the way, what would happen if you tried to go faster than light? Try putting in a value bigger than c into the time equation and see what happens. You can try that on your own. Okay? So if I convert to meters per second, I would go 0.866 times 3 times 10 to the 8th. I have my answer button here, times 3 times. If you want an answer in meters per second, 2.598. I'd probably go to 4 or 5 sig figs. 2.598 times 10 to the 8th meters per second. I did the scientific notation over here. Both of those, Emma, as far as I'm concerned, are fair game. I think in the homework I ask you for one or the other. Here I didn't specify. On your test, I'll either say, give your answer as a percentage of the speed of light, which is the easier one, because it just naturally pops out if you leave the C as a C. Or I may say, give your velocity in meters per second, in which case you got to multiply it by the speed of light. What's your homework? I already gave you. When I rather than 10, you can now handle 11, 12, 13, 14, 15, 16, 17, yeah, I'm doing them all, 18, 19. I will be putting an answer key showing all my steps online. I'm going to be insistent, because I did give you the answers here. You have to at least write out the equation, but your homework, Sierra, is a chance for you to experiment with your specific calculator and see where you can take shortcuts and still get the right answer. Because I haven't showed you faster ways to type this in. I've done the way that I know will work on any calculator. Do what's inside the square root first. Square root answer. 1 divided by, or 5 divided by, or whatever, that. But there are faster ways to get there. In fact, I'll be honest, I can type these in one fell swoop, no problem.